1 exact pixel. From a flat screenshot. No mouse feel, no page memory, just an image and a task. Here is how an AI agent turns a screenshot into 1 exact pixel click. In 3 steps. Miss by 8 pixels and you don't hit buy. You hit cancel. Or a hidden tracking link. On a live page, the agent has no undo. Break time equals 0, 6 is slash, and here's the trap most people miss. The hard part isn't deciding what to do. It's translating click login into 1 XY coordinate. On a 1920 by 1080 image, the model has never seen before. Step 1. Capture. The agent takes a screenshot of what's on screen right now. Say 1280 by 720. The exact same raw pixels a human would see. Nothing more. There are 2 ways to grab it. Viewport only means just the slice currently visible in the window. Full page means scrolling top to bottom and stitching every slice into 1 tall image. Agents usually start viewport only. And there's a plain reason why. A smaller image is faster to send, cheaper to process, and less for the model to get lost in. Break time equals 0, 6 is slash, now the part that surprises people. That screenshot is the only thing the vision model receives. No mouse position it can feel. No live sense of the page underneath. No hidden knowledge of what's a button and what's a picture of a button. Just a flat image plus the task written in words. Add this to the cart. Think about how strange that is. You navigate the web with your eyes and your hands and years of muscle memory. The agent gets 1 photograph and a sentence. Everything after this has to be reconstructed from those 2 things alone. So the next question writes itself. How do you turn a wall of pixels into a list of things you can actually click? Step 2. Read the layout. Here 2 rival approaches split apart. The first way reads the page's own blueprint. Every web page ships an underlying map of its parts. The browser can hand over a tidy list. This is a button, here's its box, here are its exact edges in pixels. Call it reading the code behind the picture. It's exact. Every clickable thing comes with precise coordinates already attached. The second way ignores all of that. Pure vision, the model looks at nothing but the pixels, the same photo you'd see, and reasons. That blue button top right, that's the one. No code, no maps. Just sight. There's a clever bridge between them. Overlay numbered boxes right on top of every clickable element in the picture. A little 1 on the search bar. A 7 on the buy button. Now the model doesn't guess a coordinate at all. It just says click element 7, and the number points straight back to a known box. That trick has a name, set of marks. So which wins? Reading the code is razor precise. Until the page is drawn on a blank canvas, or sealed inside an embedded frame, or built from custom widgets the map doesn't describe. Then the tidy list comes back empty. Pure vision never goes blank. A button looks like a button no matter how it's built. But it's fuzzier. It has to eyeball where the box really is, which sets up the real problem. Step 3. Grounding. Turning the buy button into a concrete X, why the computer can actually click. If the agent used numbered boxes or the page's blueprint, this part is boring in the best way. It looks up element 7's box, takes the center, done. Deterministic. Same input, same pixel every time. But if it's running on pure vision, there's no box to look up. So a second model does the pointing. Feed it the image plus the instruction, click buy, and it outputs raw coordinates directly. Click at 940, 512. That's its whole job. Predict where the button lives from the picture alone. These pointing models are trained on millions of screenshots, paired with the exact spots humans clicked. Either way, out comes 1XY. The computer clicks it at the operating system level. A real click, the same event your mouse would fire. The page reacts. A menu opens, an item lands in the cart, the screen changes. Break time equals 0, 6 is slash, and here's the move that makes the whole thing work. The agent doesn't trust its plan and barrel ahead. It takes a fresh screenshot of the new page. Then it starts over, capture, read, ground for the very next click. 1 perception, 1 click, 1 screenshot. Repeat. But if every step depends on a photo that's already a moment old, what happens when the page won't hold still? Now the objection. If it's this clean, why do these agents still misfire? 3 reasons. First, the pointing is just imperfect. On tiny targets and near the screen's edges, models land systematically off. Not by miles, but by tens of pixels. On a small button, that's the whole difference. Second, and this is the sneaky one, the page won't sit still. The agent screenshots, decides to click at 940, 512. And in that half second, a pop-up fires, or a lazy banner finishes loading and shoves everything down 40 pixels. The photo said buy was there. The live page has already moved on. That saved coordinate now points at empty space. Or worse, the wrong control. Third, ambiguities. Picture 3 identical add to cart buttons stacked down one page. Click add to cart is true of all 3. Grounding has to pick the right one, and a lone photo gives it no way to tell them apart. This is exactly where the page's blueprint earns its keep, and where re-screenshotting after every action beats guessing. So the fix isn't a smarter one-shot guess. It's the loop we already saw used as armor. Screenshot, select, then immediately screenshot again to confirm the click did what you expected, before committing to the next one. Never fire a whole plan of coordinates blind at a page that's still moving. Check reality after every single move. So put it all back together. Screenshot in. Layout read by the page's blueprint by Pure Vision or by numbered boxes. Grounded down to 1xy. Click fires at the operating system level. Then a fresh screenshot and the whole thing runs again for the next move. Break time equals 0, 6 is / here's the insight that makes it click. The agent never actually knows the page. It doesn't hold a map in its head. Every single action is a brand new translation, from one photograph to one pixel done from scratch. And that one fact explains both its magic and its failures at once. Working from raw pixels is why it can drive almost any website it's never seen. No special hookup required. And working from a photo that's already stale is exactly why a shifting page can throw it off. Same trait both sides. So next time you watch a slick AI does your browsing for you demo, you're no longer just impressed. You can name which of the 3 steps is doing the work: capture, read, or ground. And which one is about to break. Capture, read, ground. 3 steps that turn a screenshot into one exact pixel. But a single click is the easy part. The real question is how an agent chains hundreds of these clicks into one long task. Like booking a flight without losing its place. That's the loop we open next. Subscribe and we'll show you.